Hello students, I hope you all are doing well and doing your studies at the same time. I welcome you all to this fifth video of the chapter Force and Pressure. In this video, we are going to learn about pressure exerted by gases. Do gases also exert pressure? Let us see. Let us do some activities which would help us to explain whether gases also exert pressure or not. Before moving into this topic, let us recall what we have learnt about pressure exerted by liquids. In our last video, in which we discussed about pressure exerted by liquids, we learned that liquids exert a force on the surface of its container or on any surface of a body inside it. Liquids exert pressure on the bottom of the containing vessel. Liquids exert pressure on the side walls of the container. Pressure exerted by liquid increases with the depth of the liquid. The pressure exerted by liquid at a given depth is equal in all the directions. Well, today, as I told you, we are going to discuss about pressure exerted by gases. Do gases also exert pressure? If they do, then how can we feel it or can we calculate their pressure? Let us explore. You all must also have blown a balloon sometimes or the other, and you are familiar with how do we blow up a balloon. We find that as we keep on blowing air into the balloon is inflated and its size goes on increasing. That means, the air which we are pumping into the balloon is making the balloon swell up, or can we say that the air which is entering the balloon is exerting pressure on the walls or the sides of the balloon? Does the air inside the balloon exert pressure? Let us explore with another activity. After inflating the balloon, you all have experienced that you have to hold the balloon from where the air has been put into the balloon tightly, or else the air comes out slowly from the balloon. As you can see, why does the air come out of the balloon? The gas is pressing on the inner wall of the balloon in all directions. Once the mouth is released, the gas rushes out of the mouth due to the pressure exerted by the gas. But how do gases exert pressure? Look at this diagram. Gases have molecules in them. The molecules of a gas are in state of constant random motion. They continuously collide against the wall of the container. The pressure exerted by the gas is due to the continuous collision of the molecules against the walls of the container. Just like we calculate the pressure exerted by liquid on a surface, we can also calculate the pressure exerted by gases in the same way. So, now you may say that there is air all around us. We are breathing air, and that air also must be exerting some pressure on us. Yes children, you are very correct. There is air all around us, and that air extends till the atmosphere which is enveloping the earth. And you all know this layer of air which envelopes the earth is called as, yes, very right, the atmosphere of earth. So, this atmospheric air must be exerting pressure on all of us, right? It does exert pressure on each and every object which is there on earth, and this pressure is called as atmospheric pressure. The existence of atmospheric pressure can be demonstrated by many activities. One of such activities I have discussed here. I have taken a small can and boiled a small quantity of water in it. Now, the water is boiling in the can and I pour cold water over the can. We will see that the can collapses or it gets crumbled. Why does the shape of the can change? The can changes its shape because of the atmospheric pressure which is on it. Well, is the atmospheric pressure so great that it could crush the can? What happened inside the can that it got crushed by the atmospheric pressure? Try to find out the reason for this phenomena which you saw. Another very commonly used item which demonstrates the presence of atmospheric pressure are the rubber suckers which we use for holding hooks on the walls. You all must have seen such hooks which are just pressed on the walls so that they keep holding on to the wall, and we can easily hang our clothes and different items through these hooks. How do they work? They also work because of the atmospheric pressure. Now, look at this carefully. When I press this rubber sucker with the smooth surface down, the sucker sticks to the surface and it will not come out even when I pull it. Why does it happen? It happens because by pressing the rubber, we removed most of the air which was there in between the rubber and the surface. Now, the atmospheric pressure is acting on the rubber, whereas inside most of the air is not there and there is a low pressure region. Now, because of the difference in the atmospheric pressure from outside and the pressure which is inside, the rubber sucker sticks to the surface and will not come off easily. Now, can you relate this to the collapsing of the tin can? Let us consider another very common example where we use atmospheric pressure. We all have used straw to drink water or juice some or the other time. Why does the juice come into our mouth when we suck it? Yes, that is also because of atmospheric pressure. Can you relate where the atmospheric pressure is acting and why the liquid rises in the straw? When we suck from the straw, the pressure inside the straw becomes low because we suck in the air which was present in the straw, whereas the atmospheric pressure outside which is acting on the surface of the liquid is very high. The pressing of the air on the surface of the juice or liquid inside the tumbler or the container causes the juice to rise inside the straw. That is how the liquid comes into our mouth. Can you think of some more examples? A very common example will be the example of a dropper. We have droppers in medicine bottles and various places. We press the rubber tip of the dropper and liquid enters inside the tube. It all works because of the difference in the pressure inside the tube and the atmospheric pressure. But now the main question is, how much pressure does atmosphere exert? Is it very large? If it is, how much is it? Can we measure it? Let us see. The reason behind the atmospheric pressure is the column of the air which is present above the surface. Let us understand this with the help of a diagram. Consider a point x on a surface. Imagine an air column of unit area of cross section. Let this column extend from point x up to the top of the atmosphere. This column of air of unit area of cross section will have a certain weight. This is the atmospheric pressure at that point. the atmospheric pressure at any given point will be equal to the weight of the air column of unit area of cross section extending from that point to the top of the atmosphere. As we know that the atmosphere extends to the height of many kilometers, the value of the atmospheric pressure is great. How strong is this atmospheric pressure? This was demonstrated by Otto von Guericke many years back. The picture here shows how he demonstrated the presence of atmospheric pressure and how large it was. In his experiment, Otto von took two hollow hemispheres and joined them. Then he evacuated the hemisphere and then he tried to separate them. As you can see in this picture, he tied many horses to pull the hemispheres and separate them out, and so many horses' strength also could not separate the two hemispheres. So, now we understand that atmospheric pressure is not small, it is of very large value. Okay, let us now try to calculate something else. How much pressure is exerted on the palm of our hand? As I open my palm, a column of air is also exerting pressure on my palm. So, why is it not pushing my palm down? Let us try to find out. We can also say the atmospheric pressure on our head is also very large, because the column of air above our head is also very large. So, why do not we feel this atmospheric pressure? Let us try to calculate something. If the area of the top of the surface of our head is, let us say, approximately 12 centimeter times 12 centimeter, the weight of the air column above our head will be 12 times 12 times g, that is 1440 Newton. It means this is approximately the weight of 144 kgs on our head. So, the question is that why do not we feel this enormous pressure which is there on our head and on our body? Actually, students, we all know that there is air and blood inside our body. The air and the blood inside our body balance this pressure. You all must have heard about blood pressure, isn't it? Yes, this blood pressure also helps in balancing the pressure which is exerted by the atmosphere on us. That is why it is very serious when our blood pressure changes. The pressure of our blood and the atmospheric pressure, they are in balance with each other. If our blood pressure becomes high or becomes low, then there is an imbalance in the pressure which is not good on us. After learning about atmospheric pressure, you can very well understand that if there is a difference in the pressure inside and outside our body, then how harmful effects it will have on us. You can relate it to the crushing of the can. Let us take another example. Let us say the atmospheric air exerts a force of 100 kg weight on our palm. Now, there is an equal force exerted by air acting upwards on the lower surface of the palm. The two forces annul each other. Hence, we do not feel the pressure of air on our hand or on our palm. So, now children, you must have got an idea about pressure exerted by air, and hence the pressure exerted by air all around us and the atmosphere. Today, we learned that even gases exert pressure on surfaces like liquids do. The pressure exerted by the weight of the air column on an unit area of cross section extending from that point to the top of the atmosphere is called as atmospheric pressure. The atmospheric pressure at any point is equal to the weight of the air column of the unit area extending from that point to the top of the atmosphere. We learned that atmospheric air exerts enormous pressure on our body. However, we do not feel it because the pressure inside our body is balanced by the pressure from outside. So, students, through all these videos on force and pressure, we had a good discussion on about what is force and what is pressure. And we saw many examples and did many activities which would demonstrate the existence of force and pressure. There are many interesting activities which are going on around you, around your environment, in the surroundings, which you need to explore and explain in terms of force and pressure. I hope these videos were useful for your learning. Please go through the chapter in your book carefully and try to answer the questions. I wish you all a good health and thank you for watching the videos.